Where can we get the information on that?
I will send it out again. We sent it out at the beginning of the semester, but yes, I will send it out one more time. And first, I'm going to do the Firefox link. Boom. There's the Firefox link. And then let me do the DHA thing. Well, I have a message with both. I'm just going to pin it in the announcements. That gives you a link to the DHA page that has all the updates on it. Oh, I hope I didn't. Wait, hang on. That's that specific one. Give me 1 second. Wait, do they not have the April meeting?
Don't they have the series?
They don't have the. Okay, well, on this meetup.com thing, they don't have it updated. Darn. They have another website, don't they?
They have a Twitter. Maybe their Twitter.
Oh, Twitter. That's a good idea. So now you all can see how laid back it is. You can't really find out anything about that. Alex Hackers. They link to their meetup.com in the.
Their meetup still has the location on the events. The location doesn't change.
Yeah, it's the same location, same time, every first Wednesday of the month. So just check out that pin that I put on there, and you should come, all of you. We're gonna have to get a bigger venue with all the people we're bringing.
Can we get started now? Alright, hello everyone, thanks for coming today. This week we'll be hosting a tech talk about web application security, hosted by yours truly, Jerry. Y'all hear me okay?
Woo! Let's go, Jerry.
Can you guys hear me in the back? Cool beans. So what are web applications? I know most of you probably know what they are, but we gotta go over it just to make sure. A web application is just an application that runs on a web server. There are other types of applications that might run on the desktop, or it's meant to just be accessed locally, but web servers can be accessed by many people across the internet, and the web server can be your own computer or some other remote computer that you can access. These applications are usually accessed through a web browser, and these web browsers usually have a GUI or graphical user interface. I'm sure there are people who do web browsing without a GUI, but I don't trust those people. So you can do a lot of things with these web apps, like online shopping, banking, checking your mail, or whatever you like to do on a daily basis. So we can see that web applications actually store a lot of your sensitive data that people forget sometimes, So usually they take input from the user. One of the best ways to create a secure web application is either 1, don't deploy it, or 2, don't accept any user input. But you kind of need to do this, or else your application is not going to be very useful or interesting. But this is also the biggest attack vector that attackers can use to compromise your site. Web applications follow a client-server model, which means that the web server sits there waiting for clients to connect and to perform authentication or whatever function they need once a client connects to them. And usually the service can handle a lot of different connections at once. If it can't, that leads to some other big problems like the site crashing or kicking out other legitimate users if too many people are connecting at once. And this kind of stuff can happen either accidentally or on purpose. So what makes up a web application? Well, there's kind of two main elements. We have the client-side code and we have the server-side code. So first, the front end, which is the code that runs on the client machine. This is interpreted by the web browser, and it's the part of the application that the user can actually see and interact with and interface with. So here, your web browser will try to make HTTP requests to the server to try and fetch the content that you request. And the backend is the code that runs on the server in response to the HTTP request received by the client. Let's see, where am I? Yeah, so the backend has all the code to process your data and then construct a response that it can send back to the front end, which displays it to the user. And the logic here usually depends on the application, but usually there are some authentication or authorization checks performed here and some processing on data to make it actually useful. And by the way, there's a link at the top to ask questions if you don't have any questions. Yes, David.
Why is COBOL crossed out?
Do you write COBOL?
No.
You know anyone who does?
No.
But you could. And finally, we have the database, which is where the application stores data that it might need to fetch later. And this type of data could be encrypted passwords to perform login checks or other user data that they might want to store. So it's not like super complicated. It's just a database where you store data, but it's also very important to do correctly, since there can be a lot of sensitive data here and you don't want it getting leaked. And databases, eventually you'll kind of need one if your web application grows. You can't just keep writing and reading the JSON files forever, and databases provide a lot of speed and efficiency benefits there. Let's see. So how do we actually communicate with these web servers? Well, I just mentioned we use HTTP. HTTP stands for Hypertext Transfer Protocol. It's a standardized way for the client to communicate with the server. So how it works is the browser sends a request formatted like we see on the top. We have the method, the path, which is like what resource you're trying to get, the protocol name, and the version of the protocol, which is HTTP. And I've never seen a version other than 1.1, so I don't know how much they update that. And it also contains some other header data that the server might use to create some specialized information for you. So after receiving and parsing the request, the server goes and fetches the page that you requested and inserts whatever variables it needs, which is then rendered to the user. So HTTP is actually stateless, and what that means is every request has no knowledge of any previous request. So you might be wondering, like, how do sessions work? How do you actually persist data and not just like get disconnected every time you access a web page? We actually do that through cookies. So cookies are how you maintain session persistence. They're basically just like a key value mapping that's like, oh, username blah 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 or session ID blah blah blah. And whenever you access the web page, you send that to them, and they can authenticate you using that. So here's an example using HTTP. Hopefully you guys can read it. Not sure. So let's say I'm trying to access the CSG website. I would go to my browser, type in csg.utdollars.edu, and then what the browser does underneath is it makes a GET request to the root directory of csg.utdollars.edu using the HTTP protocol. The GET request also contains a bunch of metadata, like the user agent, what browser you're using, what operating system your computer is loading from. And I think that's most of the important things. And yeah, it accepts, what kind of response it's expecting. So the server sees this HTTP request, parses it, and then basically gives you the response that you want, which is the root directory of our web page. We can see you have the HTTP protocol and version. And then here you have a 200 number. Anyone know what 200 means? Okay, yes. So this 200 is an HTTP status code. This is like there's a standardized list somewhere of like a bunch of different codes that basically tell the clients like what's up, right? So you don't leave them hanging. Yes, David?
Do you know what code 418 is?
I don't. What is it?
I'm a teapot.
That is fantastic, David. Yes?
Why did they choose 200 to be the okay code? Like, why couldn't it be 100?
I believe they segmented like 100, 200, 300, 400, and like all the 200 series are used for like successes in various fashions. And 300 is like redirects, 400s are like failures.
How about 100?
I don't know. Do you know what 100 is? I don't know what 100 is. Well, it's probably not that common then. I mean, you can see it says 200 OK. And we can see that it renders it using HTML, or I mean, it just sends you the raw HTML because I captured the request, but your web browser will actually translate this into something your eyes will enjoy. So let's say a couple of minutes later, I accidentally close the website and I want to open it again. So I type in csg.ut.ls.edu again, and it sends the same request. You can see we have a cookie now, PTG session ID. This authenticates us to the current session. I mean, this is non-authenticated, but it still creates a session. And we can see now the response from the server is different. We have the same HTTP 1.1, but now we get a return code of 304 not modified. Anyone have a guess at what that means?
Is it a signal to the browser telling it to load the page from cache?
Exactly. Yeah, basically nothing changed since the last time you requested a website, so they're just going to tell you to get it from cache. So they don't have to spend resources on that. And the way they can check that is using this etag value. This is just like a fingerprint / hash. The implementation depends on the server, but basically they check this against the one that you currently have, and if it matches, then they tell you to use your own. And we can see that the etag word was in the original one as well. You can't see where I'm pointing. Here. Cool. Okay, so some useful tools that I like to use when I'm analyzing websites. Burp Suite. If you could only install one tool for the rest of your life and only use that, I would recommend Burp Suite. You can kind of do pretty much anything with Burp Suite since it is kind of a collection of tools. So it's kind of your one-stop shop for everything web application based. But there are some other ones that might make your life easier as well. So Burp Suite has something called a proxy. That's how you can intercept requests sent to your web browser, or that you make from your web browser. This is how I captured these packages sent between the client and the server. We have Repeater that allows you to send modified HTTP requests easily rather than entering it through the website again. And we have Intruder that has a relatively elementary brute force system, but it works for some basic things. Some other tools I like, Nikto. This lets you scan a website for vulnerabilities, so this catches a lot of the low-hanging fruits, like really obvious XSS vulnerabilities. Compares it against like existing hashes to see if your website contains anything not good. And finally, Nmap is also very useful for pretty much everything security related. In this case, most web servers are going to be running on port 80 or 443, whether it's HTTP or HTTPS. So that's not too useful to know what port it's running on, but Nmap also has some default scripts that you can run to like find out, for example, what Apache version that you're running, and that could lead to some exploits if you're using older version. Yes.
You mentioned that Nikto like scans the website for like vulnerabilities and stuff.
Yeah.
Like, could you give me some examples of like the most common vulnerabilities?
The most common would be like a slightly outdated version of Apache or something, but they're also. I need to like spin up. You know, let's try it. Do I have Nikto? No, I don't. I should have installed it beforehand. And you probably shouldn't be running this against like every web server you run up against, because you probably don't have permission unless it's your own site. But in this case, I'll scan this site because it's meant to be scanned. Okay. I just remembered I don't remember the syntax for Nikto. Nikto syntax. Google is your best friend as always. Okay. Export our IP. And you guys can see this, right?
Yes.
Cool. like nicto/page, pass in our IP. And so let's see what it finds out. So it tells us it's running on port 80, which is pretty obvious. The Apache version. Yeah, we can see simple stuff like that. Most common, it's hard to say. It depends a lot. And to be honest, on most modern websites, you're not really going to find anything using Nicto or anything important, since this is like, and anyone can run this script, right? You just saw me install it and run it within like a minute. So it's not going to find anything that's not been patched or fixed already, most likely. So we can see some basic stuff like there's no anti-clickjacking header, PHP session ID created about the HTTP only flag, and it's not necessarily going to tell you how severe these are. Some of them you might have to look for yourself, but you know, it's kind of like an information dump that you could use. And I guess this has a robots.txt. Let's check out what's in there. Nothing. Oh yeah, I guess that's a short demo of Nicto if you were curious. Any other questions there? I guess we can let it run in the background.
Is it intensive or something? Is that why you're not really allowed to run it?
No, it's just you really shouldn't be scanning computers that you don't have permission to.
That's
Right.
what my web browser does.
For vulnerabilities?
I mean, implicitly, right?
I don't think that's how that works. I guess general rule, I guess this is a disclaimer that I have to put in every presentation. Don't perform any kind of attacks against computers that you're not allowed to. Or at least if you do, don't tell them I told you that. Okay. Where's the... My speaker view disappeared. Cool. Okay, never mind. Not cool. Cool. So since we're talking about web applications, I figured I kind of have to talk about the OWASP top 10. OWASP stands for Open, I think it's Open Web Application Security Project. Basically, I don't know if they're a nonprofit, but they're an organization that collects info about web security vulnerabilities. And every couple years, they publish a list of like the top 10 web vulnerabilities that are like most likely to be at risk for your web application. When you're developing a web application, these are the biggest, most critical security risks that you should try to prevent against, if nothing else. And this is also a very popular interview question. So over time, the industry has been steadily changing and integrating security into more of a development lifecycle rather than like as an after effect. So people are realizing that having security just as an afterthought is most likely going to cause them more pain later on. So that's why you see buzzwords like DevSecOps coming up a lot nowadays. And we can see that the OWASP top 10, compared to 2017, 2021 has a lot of more design failures than pure code mistakes. So even though injection is no longer the #1 vulnerability on the list, it's still pretty high up there, so relevant still. Some other notable ones, we have authentication. This deals with problems relating to access control. So when unauthorized users can access objects outside of their rights, whether through lack of controls or some other privilege escalation vulnerability. You don't want users to access information belonging to another user or like the admin user. We also have insecure cryptography. The problem with crypto is like there's a bajillion things you have to keep in mind, or else your crypto system is insecure and literally sucks. So making sure everything is encrypted where and when it needs to be, and your crypto system isn't leaking anything that can be used to undermine the underlying effect or design. And lastly, we have misconfigurations. These are really common because developers are really lazy. and we just like to leave stuff as the default, or leave things like overly permissive, like too many ports open, too many error messages, default account and password. Those are all things that could lead to your website being compromised. Any questions here? Yes.
So is there a specific cryptographic failure that's used more than some others? That seems very general, saying cryptographic.
Yeah, it is very general. So there are a lot of different cryptographic failures. So like I would say the easiest one to say is like using a terrible algorithm, right? One that's just not modern. But the thing with cryptography, I mentioned there are a lot of different things you have to keep in mind. When people design their crypto system, for example, you have to like you have to generate what does IV stand for? I remember, but I'll let you.
I'm really thinking network security. IV. It's like an initial vector, not vector.
Initialization vector. Yeah, basically every time you want to encrypt a piece of data, you have to generate a new IV, or else your crypto system is bad. That's why there are so many problems with crypto. So this is a blanket statement, as you've noticed, that because there are a lot of different crypto failures. Yeah, like repeating IVs for one. Any more questions? I feel like I get asked about this a lot in like security interviews, because like if you know nothing else, just like read through the articles that OWASP has on these top 10 vulnerabilities. Okay. So what is cross-site scripting? Well, it originates from the fact that in order for a web application to do anything remotely useful, they need to serve dynamic content. We don't just have static HTML files being served. We use JavaScript used to embed dynamic content in your web pages. So this problem arises when the browser treats sources of input as trusted when it shouldn't. So it directly renders the web page with your input data. So if you, for example, provide a malicious script in your data, it also gets executed. And this is obviously bad, because if someone is able to, for example, steal your cookies, they can use it for impersonation or leaking other sensitive data. They can also modify the user view, so tricking you into entering sensitive information somewhere where you normally wouldn't. And then they can retrieve the data and then send it to their remote server, whatever, and use the forward request, whatever bad people do. I wouldn't know. Yeah, so there are three main types of XSS. I would say two main types and then one lesser well known. So reflected XSS is the most common. It's where the application receives data through an HTTP request and returns it in an insecure way. For example, we could craft a malicious payload that yoinks the cookies of the client and then send them to a remote server somewhere that we can control. And then we send the link to others, and when they click it, the payload gets executed in their browser. So we call it reflected because the script is reflected off the server. Like when we send it to them and then they return a malicious code that gets executed on our browser. It's also called reflected because you don't store it, unlike stored XSS. So stored XSS, the malicious payload gets stored in some database or elsewhere on your web page, and whenever someone else accesses that piece of data or web page, they also get exploited. And this is obviously a lot worse than reflected XSS because it has the potential to like propagate a lot to other users. Compared to reflected XSS, which is kind of like a one-click, one hack, or one pwn. And lastly, we have the DOM-based XSS, and this is probably the least well-known of the three types, and involves the DOM, or the document object model, which is basically how your page gets rendered. So it involves the page being run in an unexpected way. So the DOM gets rendered using your user input, and if you have a script, the browser kind of just executes it when they create your DOM, and bad things happen. And I think this is where I do my little demo. So I'll be practicing some of these attacks on DVWA. What does that stand for? What is that password? Admin password. That's probably it. Yeah. It's a damn vulnerable web application. So a very vulnerable web application, like Arterio wrote it or something. So first we're going to go to the security. They have different security levels based on how much, how bad you want the code to be, I guess. We're not going to do impossible because it's impossible. Okay, so we are going to switch it to low. And then go to XSS reflected. So we can see a simple form here. It's what's your name, we have a form, and then we have a submit button. So let's say, what is your name? My name is Jerry, and it just prints hello Jerry. So if we look at the source code, why is this still running? We can see that they're explicitly setting this XSS protection to 0. That's for our sake, so we can actually perform these attacks for practice. And we see, does anyone see something bad happening here?
They're just rendering whatever you put in the name, whatever you submit.
Yeah, pretty much. Like there's a get for your name and then insert it directly into the PHP. Insert into the PHP, which renders the HTML. So why this is bad? We can test it for an existence of a possible XSS attack if we try to write HTML when it's expecting like regular English. So let's say my name is Jerry, but more important. So we bolded, and I don't know if you can see that, but the Jerry actually got bulleted, which means that it's actually rendering the HTML, which it shouldn't do. Like normally, if you do, I should have copied that. If you do something like that, you would expect it to render like exactly as you type, right? You wouldn't apply any other modifiers on it. So we can exploit this by running JavaScript, and JavaScript is very bad because it has access to a lot of the things your browser does, and your browser contains a lot of sensitive information. So we can make extra sure that we can run stuff. If we do it is I. I'll call it that. Anyways, not very important, but the point is we can insert something more malicious. So we have the script tag, which denotes the start of JavaScript. Might be useful if you hit the help button. Okay, so this help, one way or another, steal the cookie of a logged in user. So the point that we're trying to do now is print the cookie. So we can do that by doing something like alert document.cookie.
Could you increase the font size?
Oh, yes, I can. Can you see that? So we have a script tag to start the JavaScript. Alert is a JavaScript function, and cookie is a property of the document. And then we end our script tag. If this was a secure application, it would either just render this as a literal string, or it would just tell us like, oh, you have terrible characters in your input, and don't do that. And if we submit it, we can see that it prints out our cookies. And you could go further and write some JavaScript to send these cookies to our remote server, but we're not going to do that now. Let's see. And then let's try to do the medium version of this. Medium. Okay, and this basically just increases the difficulty. So if we look at the source again, we can do it. We can see it's doing some input filtering, right? It's replacing script with nothing. Can anyone see any possible vulnerabilities here?
Is there something else you can write aside from script that will execute JavaScript?
There are actually a lot of things. So we could do that. There's also a gimmick. So what replace does? Let's say you have something like this. It basically reads it from left to right, and if it sees the string script, then it just deletes it. But if you do something like script, and then we don't end it, we write another script and then end it, this will read here. It doesn't detect the full script, right? And it'll start reading this, and it's like, oh, this is a script. So it deletes this, and it continues going on. And we can see that the script is still there, right? And then now we can just do our, oh, I deleted that. And now we can do our typical document.cookie script. It doesn't filter out the ending script. Submit it. And damn, it works. And then let's finally try the last one, which will use your idea. Let's see. What did I just do? Reflected XSS. So if we look at the source now, it's doing a smarter script, right? Basically, if we try the same thing that we did earlier, it's not going to work. It filters out all of the scripts. And so now we can do something. We still want to execute JavaScript, but there are different ways to do it. For example, HTML, I think they're called events. So for example,
Like on-click?
yeah, like on-click, on-error, on mouse over, on hover, a lot of different things. But the one I like using is on-error. I think it's easier than on-load, because on-load you actually have to provide a valid payload. So on-error, we do the source of the image equals A, and it doesn't know what A is, so it's going to throw an error, guaranteed. And we do on-error, and we can provide our JavaScript function here, alert document.cookie, and then close the image. And we can see it tries to render the image, but it can't find anything called A, so it throws an error, and when it throws an error, it executes the JavaScript function bind it to on-error. That makes sense for everyone? Cool beans. So that's some basic cross-site scripting.
What does it do for impossible?
You cannot do anything.
Okay, but can we see the source? Maybe? I'm just curious.
Yeah, you
See
can.
what it did.
If you know how to read PHP,
Yeah.
we can compare all levels, and yeah, this okay. This function will literally destroy your any type of payload. So it's literally impossible. Cool. Let me try to speed up a bit. So the root of the problem is that the website is implicitly trusting the user port or user input. So the first step is to provide server-side input validation with the data sent by the clients. You want to match the input data to the exact format that you expect the data to be. So for example, if you're having a username field, you probably don't need like a semicolon in there, unless you do it, in which case I'm sorry. And then once we send the data back to the user, we encode it again, so there's no chance of any symbols or words in the user data causing a script to be executed on their end. And there's some other stuff that you can do, but these are kind of more restrictive or niche. And to prevent something like DOM, or I guess everything in general, write better code. Like nowadays, JavaScript libraries they provide safe functions by default, and you have to explicitly use like non-safe function. It's like called dangerous function or whatever in React, I think. So the next big injection tag we're going to cover is an Sql injection. So this occurs when the backend is talking to the database. It has to make a SQL query. So this is when the user input can modify the nature of the SQL query, so that the backend makes a different request to the database that it normally intended. So this gets even worse if you're able to access tables outside of the current table and modify entries there. But this probably requires some more probing. And the actual syntax of this depends a bit on the DBMS that's being used, since they all have different syntax. And obviously this can lead to some very bad things, modifying or deleting other users' data, retrieving data outside of your access level, or a denial of service attack if you like drop tables, like Bobby over there. You guys have all seen this, right? Bobby tables? Okay. So here's a basic example of how a SQL injection will work. We have a normal looking SQL query. Select all from users where email equals email input and password equals MD5 hash of the password that you input. So that's all fine and dandy. So let's say for email we can supply whatever, and then for the password we supply this email or this password. So what this will do is it just directly substitutes our password into here. So we can see let's see, MD5. And password equals. Yeah, so what it's doing, we have the open quotes, then we have the free access, and then we close the quotes, close the parentheses for the MD5 function. Then we do an or 1 equals 1, which is a tautology, if you remember that from discrete. It's always going to be true, and then we comment that out to prevent anything later on from affecting us. So what this evaluates to, where email equals blah, 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 you assume that's false because we just provided a random email. And password equals MD5 XXX, that's also going to be false because we provided XXX instead of an actual password. So these first two evaluate to true, or sorry, evaluate to false. And then we have this last tautology which always evaluates to true. And the goal is to make the condition always evaluate to true, because in that case it's basically like there is no condition. Yeah, so we can see it ends up being select all from users were true, which is basically the same as select all from users. So dump the whole users database. And what time is it? 7:49. Okay, let me do a quick demo of a Sql injection. And by the way, cross-site scripting and Sql injection have really good cheat sheets by Portswigger. These are the people who made Burp Suite, so they know what they're doing. I'm live streaming. Oh. Let's see. We're gonna change it back to low. Okay, we have this pretty basic SQL injection problem. It's asking for a user ID. Put in 0, there's nothing there. Put in 1, we have admin. 2, 3. So what exactly is the point of this problem? If you look at the help, there are 5 users in the database with IDs from 1 to 5. Your mission is to steal their passwords via SQL injection. So the first way that you could use to test whether this is vulnerable to SQL injection is try to put in some syntax that's specific to SQL. For example, maybe this, which denotes a comment. Actually, we want to actually throw an error. How do you throw an error? Oh, maybe something like this. Yeah, you have an error in your SQL syntax, and conveniently it tells us that it's using MySQL, which this is also a vulnerability. It's telling you too much information. You don't want to tell people, I mean, they can find out, but you don't want to tell people explicitly like what SQL you're using, or else they can just, it's easier for them to find the correct syntax. So the first thing we can do, actually we can look at the source here. More beautiful PHP. We have the query here called select first name, last name from users where user ID equals ID, where ID is your input. Can anyone think of any ways that we could exploit this query?
Escape the string of the quote.
Yeah, so we have user ID equals begin quote, but we can actually end that quote. So maybe it'd be easier if I copy this somewhere else. Okay, so we have this query that's being executed. Right. If we manage to escape this, it will basically check user ID equals blank. And then here we can execute any arbitrary SQL. Oops. Yeah, you guys can see that. Here we can execute any arbitrary SQL command that we want. So we want to insert a tautology here. So like, let's say for example, or 1, this ID gets replaced by our input. 1 equals 1. I think there was a apostrophe there. So our user input is this part, right? So if we try running that. There it is. So if we select it, 1, 1, 1, So this is basically checking whether the user ID equals 1 or 1 equals 1, which is always true. And we can see that it dumps all of the users in the table, which isn't very useful because we could have accessed it normally by doing this. But the point is to dump their passwords, right? So I feel like explaining it actually would take a little bit too long, but basically the way you would do this is there's an operator in SQL called union select, which basically allows you to concatenate the results from one table into the results of another table. And the restriction on that is the tables have to have the same number of columns, I believe. Same number of rows.
You can select the columns to pick from.
Yeah, you can. But if you do select all, then you don't know which
that's
ones.
True.
So let's see, let's try out the union select. So this is basically checking where ID equals blank union select. And if we go to this cheat sheet, we have union attacks. And one common one you can do is union select username password from users. Let's try putting that in there. Submit. And it tells us unknown column username and field list. So it looks like the users column doesn't have a field name username. Can anyone think of anything else that could be indicative of a username?
I don't know with MySQL, but with SQL, you could run schema and find out what all the column names are.
You could, but that would take a long time. Or you can just guess. You can also just guess user, yeah. And here we can see that it's dumping all of their password hashes in here. So SQL injections a lot of time do require a lot of trial and error, kind of guessing. That's why you're kind of stupid sometimes.
Because you can't see the database content?
Yeah, you can, and normally they don't like provide you the source code and their terrible code that they're running, right? Let's get this on here. Okay. So some defenses I'll try to go over just quickly. Use prepared or parameterized statements. So a lot of ORMs or object relational mapping libraries provided in like high-level language will do this for you. You don't like run direct SQL queries. You kind of call a function that's like, oh, get one from the table or something like that. I always thought they were stupid, but it turns out they're actually useful. So this allows you to define SQL code, then pass in your parameters later. And then you can also do input validation, only allowing certain phrases or characters into the database, escaping input, removing special characters from the user input. Let's see. So one good general way of defending against attacks targeting web applications is using a web application firewall or a WAF. Some of you might be familiar with traditional firewalls, which protect internal networks from unwanted traffic. So to explain the difference between a traditional firewall and a web application firewall, I think you need to know a little bit about the OSI model. The OSI model is basically a model describing how the internet works and how packets are encapsulated and sent between different devices. And as you move closer to the lower layers, you get closer and closer to the actual hardware. For example, at the bottom you have like pure wires. And as you go up the layers, you start running into a lot more software, like your HTTP, DNS, SMTP protocols. So basically, it's just an abstraction for how the internet works. So like, whereas a regular firewall acts on layers 3 and 4, which are the network and transport layer, the web application firewall works on layer 7, which is the application layer, which deals with HTTP requests, like we saw earlier. So each layer just represents an abstraction of the data that's visible to that layer and provides protocols to interact with the layers above and below them. So for example, with a firewall, you could allow connections from like only a certain IP range because the network and transport layer have IP addresses in their headers, and everything else is encrypted. But once you get up to the application layer, all of that IP stuff gets decrypted, and you can see the actual data that's included in your request. Yeah, so web application firewalls, they can protect against most of the OWASP top 10, There are some that are like configuration issues or like stupid people issues that you can't really protect against with a WAF. But it doesn't hurt to have. So it basically sits between the client and a web server. And before a packet reaches the web server, it goes through the WAF, which inspects packets to check for any malicious payloads, and it's highly configurable with policies for each set of attacks. So you can customize it however you want. I can give a little bit of a demo because DVW actually includes a web application firewall called PHP IDS. It's not super good, but it does some basic stuff. So let's enable it. And if we go back to the reflected XSS we tried earlier, anyone remember the payload?
On low security? On low security?
This is for, low security.
Scripts. Alert. Document.cookie.
Document.cookie, yeah. And then you close your script tag. So this just runs this JavaScript function. And when we press enter, normally it would give us a little pop-up saying, oh, here are your cookies. But when we do it now, we have hacking attempt detected and logged, have a nice day. And that's the intrusion detection system offered by the WAF. So this isn't going to cover everything, obviously. It's not a one-stop shop, but it will cover a lot of the low-hanging fruit that people will try to spam at you. Any question? Go beans. Let's see. I'm not sure if we have time to cover Sql Map. Maybe I'll go back to it in a bit. Actually, I think the other one might be more interesting than Fortnite vulnerabilities. But if you haven't heard, like a couple years ago, Fortnite did get, or Epic Games got hacked. Not hacked, their users got hacked by a combination of phishing, forgotten subdomains, token authentication, and WAF bypass. And this was a combination of cross-site scripting and Sql injection attacks. So if you're wondering if these attacks are still relevant nowadays, they are. They just require a bit more like phishing to get the initial payload on there. Yeah, so I can cover Sql Map a little. So you know how painful the Sql injection was, and they only get worse. So we have a handy dandy tool called Sql Map. So Sql Map is kind of like, well, a skip kitty's dream, but also it automates a lot of common payloads for Sql injections depending on what parameters you have already. So I have Sql Map downloaded here. If I run it, Sql Map, that should help. Yeah, we can see that there are some options we need to provide, like URL, cookie, data if we want to do a post request. So let's try out the same. Let me check, it's not going to die. Okay, fine. Let's go back to the same Sql injection and see how we might be able to tackle it using Sql Map. Is it okay? Oh, I forgot to put the question thing on there. Oh. Seems like it's not loading through. I'm gonna kill it and restart it. Is everyone following along so far? Anything I need to go back over? Wait a minute for this machine to deploy. So I guess a little precursor to Sql Map. You can look at their GitHub here. it's a pretty common tool for pen testers because no one wants to try like 10 million payloads for SQL injections. There are actually a lot of them. Actually, the Wi-Fi in general is kind of bad. Is it just me?
This happening earlier today for me.
Yeah, there's a lot of things you can do with SQL injections. This is not even a fraction of it. Might take a bit to load up. Maybe, hopefully. Wait. I'm not connected to VPN, am I? Let me try again. Okay, I don't really know. I guess the Wi-Fi is being weird today. But I guess that's most of the important stuff we need to cover. Maybe we can do Sql Map another time. Anyone have any final questions here?